Next up, we have Derek Cunningham, who's an enthusiast in electronics, who also joins us at the Raspberry Pi Jam that we hold up here in the Malvern Hills. And he's going to talk a little bit about software-defined radio and how it can be used for weather stations and monitoring aircraft.
My name is Derek, and in this short presentation I will give you a brief look at the interesting hobby of working with software-defined radio, usually referred to by the abbreviation SDR. The first demonstration I'd like to talk to you about is using SDR in the application of collecting weather data and sending it on to other users. I first became involved with software-defined radio when I bought myself a weather station for the garden, and for several years I have transmitted data to the meteorological office of the UK directly from my garden. This is some of the current data that I'm sending out. As you see, it goes off to the Met Office website, which is called WOW, World of Weather. And you see, I'm not alone in this task. There is a massive, huge number of people all using their weather stations to transmit the data back to the Met Office. Now, all of these users are using software-defined radio, although they may not understand that's what they're using. Anyway, my first weather station broke, and I now had to buy a new one, which is this one here. This machine transmits information by radio at a frequency of 868.3 megahertz to this ground base station, which shows all the data that's currently been picked up. On the top left, from the top left down to the bottom, we've got temperature, we have outdoors and indoors, we have the date, we have the day of the week. In the centre column, we have the wind direction and speed, and so on. That data is then sent over my Wi-Fi onto the internet to a station to a service called the Weather Underground, which is in America. But my main allegiance lies with the Met Office in the UK. So I have to think of a way of taking this data, packaging it up, and reconfiguring it to the format that is required by the Met Office. So here's the software-defined radio in my laptop at the moment. Later on we'll be using it in the Raspberry Pi. And I'm just simply showing how simple this is. The black line coming out from the right-hand side, it goes to the antenna. And using this software, I'm able to investigate the radio spectrum to see what signals are around. Now at the moment, the radio is tuned to the 868.3 megahertz of the weather stations, and you can see every so often there's a burst of data comes over, and that burst of data is carrying all the numerical data for the current weather situation onto that base station. You can't really tell from this display. This simply shows you what the radio frequency and atmosphere is looking like. So this time I've tuned it now to Classic FM, which is a much more pleasant sound to listen to. And at the lower part of the display with the bright green line on it, that's simply showing, this is a frequency display that moves on in time. So it's a time-based frequency display, and as the frequency changes, you can actually see that happening on the signal that's there. So for the next demonstration, we're going to move on to another weather sensor. This is designed to be an outstation from the main weather machine, and this is a little one that's tuned at 433 megahertz, and we're using the SDR plugged into a Raspberry Pi to receive the data, translate it, and this is the Raspberry Pi screen showing where the information what the information is that's been picked up. Not very clear on this particular, but all these single lines of data. Each new line of data is the ones with the blue date time groups on it. And as each one comes in, you see the latest pulse of data coming from that small 433 megahertz transmitter. So here is the SDR plugged into the Raspberry Pi. So the signals coming from the small sensor is interpreted by the radio and then is decoded and displayed on the website, or on the screen, sorry, through the Raspberry Pi. This next demonstration, we've now tuned the SDR to 1.09 gigahertz, which is 1090 megahertz. And that frequency is the frequency of an aircraft tracking system called ADS-B. Each line of data that comes from that is shown now scrolling at the bottom of the screen. And you see it's just a fairly unintelligible block of numbers. So that block of numbers has to be taken into the Raspberry Pi, into the software there, decoded, and is then able to be sent to be displayed on a web page. And here we have got that same data actually being shown on the web page. We have a track down here which looks to me like a C-130 from the RAF, and here we see the data scrolling past on the right and the actual radar picture, or the ADS-B picture, displayed on the map of England. So here we have Gloucester and Birmingham, and the black dot is right where my house is in Malvern. So what can we do with this? We have a look at this aircraft, we click the aircraft, a data plaque comes up that tells me its call sign, the aircraft type usually, the altitude, and what speed it's doing. And once we know that information, we can go to the tabular data that's available and click on the same call sign that we've just been looking at, and it takes us to a new website where you can learn all there is to know about that particular flight. We have the find out that it's coming out from Hebron in Kentucky in the USA, and it's flying to London Heathrow. So this gives us a full picture of that particular track, all through having detected it with SDR and decoded the data through the Raspberry Pi. I find that to be a fascinating process, and that's why I thoroughly enjoy working with this form of technology. But I have to admit that the real reason I started with this was to get my Met Office data back running directly from my new weather station, and that's now working quite well. Excuse me. So as time goes on, the tracks, you can see, they just keep developing. I've now managed to pick up, this is an aircraft called a C-17, which is the RAF's largest cargo aircraft, probably flying out from Brize Norton on a training flight. And again, the data there is coming in, flowing in from the right-hand side there, because they all use the ADS-B for anti-collision purposes and various other, and just general tracking of where the aircraft is. So that's all we have to say. I hope you've enjoyed our demonstration, and we'll look forward to seeing you next year at Science in the Park when we're outside.